So now let's see how to find out the determinant of a 3 by 3 order matrix, right? So first we are having A matrix as this one, we have to find the determinant, right? So for this one, first what you have to do, I will teach you the easiest method. The first element is there, right? So take it out, A11, you have to multiply it, put inside bracket, cancel this row and cancel this column, right? This row and this column you have to cancel out. So whatever is there inside, what you have to do means you have to take the determinant of whatever is inside. So this row is gone and this column is gone. So what is left? It will be A22, A23, A32 and A33, right? With this, what you have to do, this is the first part of the determinant. Now what you have to do means we have to take the second element now and cancel out that row and cancel out that column. Now we have to take the negative, right? We have to take the negative for the second element, right? First element is positive, second element is negative, and third one will be positive. So what we have to do now, take the determinant of whatever is left out, A21, right? This column and this column is left, right? These two elements and these two elements, A23 and A31 and A33. Now with this you have to add the third element multiplied with the determinant, right? Now if you check this row, it is there, right? But this column will be cancelled out. So whatever will be left out, these four elements will be left out. Now what we have to do means just take the determinant of this element and this also and this also, then this has to be multiplied with this, minus this has to be multiplied with this, and plus this has to be multiplied with this. So if you do all these calculations, you will be getting the determinant for the 3 by 3 order matrix. It's a little bit lengthier than the 2 by 2 order matrix, but you can do it if you know the steps. It's really easy. So as we were discussing, for a 3 by 3 order matrix, right, the first element, it's taken as positive, second one is taken as negative, right, and the third one is taken as positive, right? Why it is the second one only it's taken as negative, we are going to discuss that. If you see here, the first element, it's like in the first row and first column, right? Now if you add both these things, 1 plus 1, it is 2, right? So when it is an even number, it will be positive. But if you check here, it's in first row and second column, right? So if you are doing 1 plus 2, it's actually 3, right? It's an odd number, and because of that it is negative, right? And here if you check, it's 1 3, right? 1 plus 3 would be 4, which is an even number, that's why it is positive, right? So if it is even, it will be positive, and if it is odd, it will be negative. You can do it in different rows also and different columns also. Maybe you can take this as the primary row and you can do in this order. For example, if I'm taking this and I can cancel out this row and this one, and I can do like this, right? Find the determinant like this, then take the second element as this one, and I can do like this versus this and like that. So you can do it in any row and any column, but this is the easiest way to do, and it's very simple to do in this way. Next we are going to discuss one property. So first, if you check, this is our A matrix given here and this is the B matrix given here, right? If you compare A and B matrix together, you are having 2 here and 1 here, 6 here and 3 here, 4 here and 2 here. So B is like half of A, right? So otherwise you can write it as A is equal to 2B, because B multiplied with the number 2 will give you the A matrix, right? So for that, what we have to do means, first let's find the determinant to prove this property. right? So determinant of A, let's find out first. 2 times 4 would be 8, minus 6 times 0 would be 0. So answer would be 8 for the determinant of A. Now let's find the determinant of B. So for that, what we have to do means 1 times 2, that would be 2, minus 0 times 3 would be 0, which will be equal to 2. So A is actually equal to 2B, but determinant of A, it's actually 4 times determinant of B. So how we can arrive at this kind of assumption? For that, we have a property. If A is equal to KB, right? A, instead of K is a constant, it's 2 here, B, right? So for that, what we have to do means, then determinant of A will be equal to K. K is the constant already given, raised to the power n determinant of B. So what is this n? You will be asking, right? So n is the order of the matrix. Order. So if you check here, the order of both the matrices are like 2 by 2, right? So n here will be 2. You can check out this property here also. Determinant of A is 8, right? Determinant of A is 8. Is it equal? Let's check. What we are having K here, we are having it as 2 raised to the power n. What is the order of the matrices? Both have the order 2, and determinant of B is 2 itself, right? So 2 square would be 4, and 4 times 2 would be 8 itself. So like this you can prove the property. Determinant of A is equal to K raised to the power n times determinant of B, where n is the order, and this condition works out only when A is equal to KB, right? So now let's do 3 by 3 order matrix and find out the determinant of that matrix. So first of all, you have to take out the first element 0, and you just close the row which is corresponding to it and the column which is corresponding to it. So what will be the leftover elements? You have to take the determinant of those, right? So this is the first part. First element should be positive and second element should be negative. So second element is 2 here. Now you have to take the determinant. Let's find out what are the elements. So cancel out the this row and cancel out the column which is corresponding to that element which you have chosen, and the leftover elements would be 5, 2, 6, 4, and third element will be positive which you are choosing, and it's 3, and you have to close this row and this column, this row and this column. So what will be left over? 5, 1, 6, 1. Now you have to find out the determinant. Here it's actually 0, so 0 multiplied with any number it would be 0, right? So it will be 0 itself, minus 2 times. Now you are finding out the determinant, so let's do it. 5 times 4 minus 6 times 2 plus 3, then 5 times 1 minus 6 times 1. Now let's do it. Minus 2, 5 times 4 would be 20, and 6 times 2 would be 12, plus 3 times 5 minus 6, right? Then 5 minus 6 is minus 1. So 3 into minus 1 would be minus 3. 20 minus 12 is minus 8. Sorry, plus 8, right? So 20 minus 12 is plus 8, and minus 2 into plus 8 would be minus 16. Then here we are having a minus 3 also. So minus 16 minus 3, you have to just add the numbers and put the negative sign before. 16 plus 3 would be 19. So both are negative, so it would be minus 19. So this is the required determinant of this matrix.